Good evening, guys. Welcome to my YouTube channel. So, as of now, we have completed two sessions. Okay, we discussed about networking, and then network devices. As of now, we covered those topics in last two sessions. In today's session, we are going to discuss about OSI model and TCP/IP model. TCP/IP model. So, before going to start OSI model, uh, you know I have to tell you few things. Okay, so if you have any doubts in the previous sessions, session 1 and session 2, I'm requesting you to please post your comments so that I can respond to your comments. Okay, and also I'm seeing majority of the people are watching my videos, but they're not subscribing the channel. If you can subscribe my channel and you know like the video, you'll get my notifications, and then you'll get my videos whenever I'm uploading. Okay, thank you so much for going through the classes. uh, yeah, so let's start the today's session. So in today's session, as I mentioned, I'm going to discuss about the OSI model and TCP/IP model. So here I'll be explaining in very simple way. Okay, so it's for whoever want to know about OSI model and TCP/IP model. It will be very easy method which I'm telling you. Okay, so OSI model is nothing but open system interconnect model. Say open system interconnect model. So here what we need to understand, why OSI model came to the picture, what is the use of OSI model, that you need to understand. So OSI model it was introduced by the ISO in the year 1984. ISO in the 1984. So ISO means International Standard Organization. It was introduced. Okay, so ISO is the one who is introduced the OSI model, Open System Interconnection Model. Okay, open system interconnect or interconnection model. So what is the purpose of this module? Why we need this module? That you need to understand. So before 1984, okay, so for example, companies like Apple, IBM, the other companies, whatever MNC companies, multinational companies or product based companies which we have, if they want to communicate from one particular location to another particular location, or from one city to another city, or from one country to another country, so the data should have to go from internet, right? So that means, if let's take some example. If you want to transfer the data from Hyderabad to Bangalore, okay, you have company like Hyderabad, okay, and you also have company in Bangalore. If you want to communicate from your Hyderabad system to Bangalore system, okay, then you have to go through internet, right? So through internet, if you are transferring something, okay, in internet, different kind of people will be there, like good people and bad people. So bad people in the sense like hackers, they'll be planning to steal the data whatever you are sending, right? So they will sit in the internet, and they will see like what type of data is transferring from one place to another place. If they are not sending properly, then they will steal that information. Okay, so before 1984, okay, so what will be happening, so if something is they want to transfer, if something they want to send from one particular location to another location, um, they need to come up with some plans. They need to set some process. Okay, companies like Apple, they introduced some process called Apple Talk. Okay, similarly, the other companies, they started their own process, they started their own methodology to transfer the data. So these all things are observing by the ISO, International Standard Organization. So what they have decided, let's introduce some new process, okay, which will help full for everyone to transfer the data securely instead of sending with their own process. Okay, we can introduce one standard process. With that standard process, everyone will uh, go and transfer the data from one system to another system securely. Like that, they introduce the OSI model. OSI model is a open system interconnection model. It was introduced by the ISO in the year 1984. Remember, it's a reference model, guys. It's a reference model. So in this reference model, total we have 7 layers. We have 7 layers. 7 layers. So application layer, presentation layer, presentation layer, session layer, session layer, okay, transport layer, network layer, data link layer, and physical layer, data link layer and physical layer. So here application layer is the top layer, 7th layer. Presentation layer is the 6th layer. Okay, session layer is the 5th layer. Transport layer is the 4th layer, and this one is the 3rd layer. Data link layer is the 2nd layer, and physical layer is the 1st layer. Okay, so so what exactly is happening with this OSA model? So let's take one example to understand clearly. Okay, for example, if I want to tell you with some example like how it will work, what is the use of OSA model? Imagine, okay, you want to send some important letter to your friend, okay, who is staying in the other city. Okay, so what you will do, you will write the letter, and then you will put that letter in envelope, and then you will give the letter to post office guy, and that post office guy will send that, okay, from that particular location to uh, uh, you know to different location, like wherever your friend is staying. Example, if your friend is staying in Bangalore, and if you are sending from Andhra or Hyderabad, so what you will do, you will write the letter, and then you will put it in the envelope, and then you will give it to post office guy, and that post office guy will send that one to the Bangalore. Okay, so that's exactly how computers will talk with each other through these layers. If you want to communicate from one particular location to another particular location, in between, this OSM model, reference model, will come to the picture. Okay, so application layer is the top layer. So let me put this into you know paint so that I can write it easily. Yeah, good. So the thing which you need to remember, these 3 layers, whatever above 3 layers, okay, we have those 3 layers, we will call like application layers or software layers. And these 3 layers, network layer, data linker, physical layer, we will call like hardware layers or network layers. Hardware layers or network layers. And this transport layer, it is the heart of OSI model. Heart of OSI model. Remember these 3 layers, okay, we will call software layers, software layers or hardware, software layers or application layers. Okay, so software layers or application layer, and this layer we will call like art of OSI model. Heart of OSI model. And finally these layers we will call like hardware layers or network layers. Hardware layers or network layers. Clear? So total we have 7 layers. Okay, above 3 layers we'll be calling software layers or application layers. Below 3 layers we'll be calling hardware layers or network layers. And middle layer, that one transport layer, we can call as the heart of OSI model. If we consider one person, okay, heart where it will be there, middle of the area, right? So on top of that, that person will have head, and below that he will have the legs, right? So just example I'm saying, so it is middle. Okay, so transport layer is the middle one. That's why we'll be calling like heart of OSI model. Okay, so what exactly we are going to do with these layers? What exactly we are going to do with these layers? What will be happening in each layer? That we need to understand. So here, for your understanding purpose, very simply I'm going to tell you. Okay, so don't go in depth. Okay, we're not going for network engineer or something else. Just for understanding purpose, go understand the layers, each layer. Okay, step by step. So application layer means application layer. In the name itself, clearly it's saying application. So application or software are same only, right? So application will run with the software. So we will have some applications, right? Like Google Chrome, Internet Explorer, Mozilla Firefox. These are the some applications. What is the use of those applications? What we will be doing with that applications? Using those applications, okay? So what we are doing, we are communicating with the services. Services means like Gmail, Yahoo, Facebook, YouTube, some other things, whatever you want, right? Using these applications only, you will be accessing it and you will be going through that, right? So application layer, what it will do means it will give you the user interface. It will give you the user interface to interact with the services. It will give you the interface, user interface to interact with the services, to interact with the services. Remember this one. Okay, that is a function of, application layer. Then what is the function of presentation layer? Presentation layer, what it will do means it will convert the data into the standard format. It will convert the data into the standard format. It will convert the data into the standard format. It will convert the data into the standard format. Okay, for your understanding, let me tell you. So when you type Facebook, okay, so if I open the Google Chrome is the one, right? So for example, if I type Facebook, okay, so what it will do, it will provide me the results of the Facebook. And then if I click on the Facebook one, if you could see here, this information I have not added. HTTPS, okay, uh, uh, /www.facebook.com. Okay, so only Facebook we've entered, but backend it will be automatically converted to the standard format. That function will be taken care by the presentation layer. That function will be taken care by the presentation layer. Remember this one. And what session layer will do? Any idea what session layer will do? Session layer, it will do, okay, to maintain the sessions, to create the sessions, and to terminate the sessions. The session layer will work. I mean to select session layer will take care of the creating the sessions, maintaining the sessions, and terminating the sessions, it will create the sessions, create the sessions, maintain the sessions, and terminate the sessions, okay. That is a function of the session layer. So for example, so if you remember, if you are logging into any net banking, like or secure ones, net banking, or to any secure websites, okay, so it will ask you to enter the OTP after entering your username and password. And if you are, and you, that OTP will get to your mobile number, right, or through your Gmail, to your Gmail you will get that OTP. So if you are not entering that OTP within the time frame, like 50 seconds or 1 minute, so if you are entering within the time, then it will log into your application. If you are not entering that, within the time, then what will happen? Then what will happen? That session will be expired. You will get the pop-up like session ID has been expired, session has been expired. That type of pop-up you could see on the screen. So that function will be taken care by the session layer. Okay, and then the next one, transport layer. It will be very important. So what session layer will do means, whatever data is coming from the above three layers, these three layers, that data it will move to below three layers. Below three layers. That is a function of the OSM model. Sorry, that is a function of the transport layer. So transport layer is a heart of OSM model. What it will do? It will send the data. It will send the information from above layers to below layers. That is the function of the transport layer. In this transport layer, you will get TCP and UDP concept. TCP and UDP concept. Anyone aware of TCP and UDP concept? Do you guys aware of TCP and UDP concept? TCP and UDP. TCP and UDP means, TCP means transmission control protocol. Transmission control protocol, and UDP means user datagram protocol. Okay, user datagram protocol. So what it will do, in TCP, okay, see, remember, TCP and UDP we will have total 65,535 36 ports, 65,536 ports. Don't confuse like what is this ports, what is the use of these ports. In next class we are going to discuss about the port numbers. Okay, there you will get full clarity on the port numbers. You don't need to worry on that for now. Okay, so total we will have 65,536 ports. Okay, the range is 0 to 65,535. Okay, including 0 we will be saying 65,536. So we will have both TCP ports and UDP ports. In TCP we will have 65,536 ports. In UDP also we will have 65,536 ports. So what is the difference between TCP and UDP? That you need to understand. TCP, transmission control protocol, guys, it will follow the three-way handshake. Remember this one. It will follow the three-way handshake. Three-way handshake. In UDP, it won't follow the three-way handshake. It won't follow the three-way handshake. Next question, it won't follow the three-way handshake. Immediately, you will get doubt. What is three-way? What is three-way handshake? I'll tell you. Three-way handshake is nothing but, for example, if there are two systems, okay, system A and system B, system A and system B, system A and system B, two systems are there. If these two systems want to communicate with each other, first what system A will do, it will send the synchronized package to the system B. It will send the synchronized package to the system B. Synchronized packets. System A will send the synchronized packets to the system B. And then system B will respond. System B will respond synchronized plus acknowledgement. So what it is telling, I'm here, I'm here, I'm acknowledging I have received your packet, synchronized packets. Like that, system B will respond. Synchronized plus acknowledgement. Whatever we send, system A sent, along with that synchronized packets, it will send the confirmation like synchronized plus acknowledgement. Finally, system A will send acknowledgement packet. It will be saying like, okay, got it, acknowledged, you are there, I got it, thank you. Okay, like that, it will say the acknowledgement. This three-way process we will be calling like three-way handshake. Okay, three-way handshake. System A will send the synchronized package to the system B. B will send the synchronized plus acknowledgement package to the system A. And finally, system A will send the acknowledgement package to the system B. Acknowledgement package to the system B. This entire process we will be calling like three-way handshake. This will be happening in the TCP. In TCP, three-way handshake will happen. So as it's following the three-way handshake, okay, it's very secure one. It's very secure one, because if other system is available, then only it is sending. Otherwise, it's not sending the information, right? It's not transferring the data, right? So that's why TCP is a secure one. UDP is not a secure one. Not a secure one. Okay. And data transfer is very slow here. Data transfer is very slow. In where data transfer is slow? In TCP. Why? Because it is checking, right? It is checking. So that's why it is slow. In UDP, data transfer is very fast. Why? Means it won't check anything. Whether that other side person is available or not, I don't care. I don't care. Okay. I will send the data. If that person is available, data will be sent. If person is not available, then data will be lost. I don't care on that. Like that, UDP will work. Okay. So the best examples for TCP and UDP for online net banking and all, we will go with the TCP. For secure connections and all, we will go with the TCP. And coming to UDP, as a best example, live streaming. Okay, so live streaming cases we will be using the UDP. For marriage functions and all, we'll be using the live streaming, right? That time they will use the UDP ports. And even in olden days, if you remember, uh, we have the antenna, using antennas we used to watch cricket. Remember Doordarshan? So there will be antenna. Okay, that antenna will pick the signals and it will give you the picture to you, right? So if something is not coming properly, if something is missing, then in between suddenly the screen will stuck. Example, like if Virendra Sehwag is hitting the six, in between that screen will stuck, and suddenly you could see some scratches on the screen, or something went wrong on the screen. It will be stuck there, and after 3 to 4 seconds you will get to know what happened, like might be six or might be out, right? So that comes under UDP. So UDP will send the information, other side person is there or not there, it won't bother. If other side person is picking properly, then the data will be shown properly, otherwise the data will be lost. Okay, clear? Okay, hope it is clear. So that is about TCP and UDP. So here, why I'm raising that TCP and UDP means, here in transport layer, the TCP and UDP concept will come from above. They will say it is a TCP related port, send that information using TCP. Okay, send that information using UDP, like that. So based on that, this transport layer will send the information to below layer, network layer, below layer. Okay, in network layer, okay, a router will come. If you remember, when we are discussing about the topics network devices, I said router is a layer 3 device. So here router will come. Router, what it will do, it will identify the best path. Based on the best path, it will move the packets from one network to the another network. That is the function of the router. Okay, that router will come in the network layer. And then in data link layer, switch will come. Switch, what it will do, it will maintain the MAC address table. Based upon the MAC address table, it will move the frames from one system to the another system internally. That is the function of the switch. And in physical layer, the data will be in bits. Okay, the data will be in bits, and then the data will be converted from bits to signals. From bits to signals. So example, like if you want to transfer the data from one particular place to other place, then what will happen, the data needs to go from bits to signals. It will convert to signals, and then through cables the data will go from your particular location, from Bangalore to other location, like sorry, from Hyderabad to other location like Bangalore. Okay, so cables will come into the picture. Okay, so the main agenda of OSI model is like we are transferring the data from one network to another network, or from one place to another place, or from one system to another system securely. So for that we need to use the OSI model. In each layer one function will happen, and finally it will go to other location. So same process will repeat here as well. So if you are sending some information from here, okay, let's assume this is the system A, and we are sending that data from here to system B. Okay, so again this all 7 layers will come to the picture. So whatever is happened here, okay, so that we will say like encryption or encoding. So that will happen this side, okay, this side, and then here again all those information will decrypted step by step, like whatever was happened from here it will bits from bits to signals it was happened, right? Okay, so to tell you, bits will be converted to signals. Once it went to this side, again the signals will convert to bits, and then same thing. Okay, so let me tell you one more thing. So in these 3 layers we will call data like data only, user data. We will call user data. In application layer, presentation layer, okay, presentation layer, session layer, we will call like user data. Coming to transport layer, we will call like segments. Segments, okay, we will call like segments. In network layer we will call like packets. Data will be in packets. Data link layer it will be in frames. And finally in physical layer it will be in bits. While transferring, it will convert from bits to signals, and it will go to next system, right? There again everything will be repeated, and finally it will go to the destination. As I said, if you want to send any letter, or if you want to send any gift to your friend, okay, like we are writing the letter, right? Or we are packing the box, and then we are giving to the package, I mean to say like tea, then they'll be sending via courier, right? So like how securely we are sending, so like that this OSI model will secure your data step by step, and then it will send to the other system. This is the OSI model, reference model. Okay, so till here you want to know, okay, if you know till here that would be enough. But if you want to know more about what type of attacks will happen in these layers, okay, that also we can discuss. But this time I won't discuss much about that, because we have a separate topic on the attacks, security, and security basics, and security important of the important attacks in cybersecurity. So there also we are going to discuss on the attacks and types of attacks. Okay, generally if I want to tell you in physical layer what type of attacks will come means, okay, so just note it down. If we have if you are maintaining the notebook, okay, just note it down. In physical layer, wire tapping, okay, so wire tapping will happen. That means listening to signals on cables, like what is going through the signals on that cables. Okay, so that type of attack will call like a wire tapping. Okay, and signal jamming, like blocking Wi-Fi or radio signals, and then you know doing the attack. That type of attack we could see in the physical layer. So what we need to do for this, what are the mitigations to stop these attacks? Means we have to maintain the physical security, like logs, okay, keeping the CCTV, and placing these all things in restricted area. We have to do that, okay. And then we have to maintain the shielded cables, fiber optics, okay. These are all things we have to do as a mitigations to protect from these attacks, like white trapping and signal jamming, okay. And also like we can say hardware theft and tampering. Or to avoid that attacks we need to follow these mitigations. Okay, coming to data link layer. In data link layer, okay, we will have kind of mac spoofing. Okay, mac means you guys are already aware of, right? Media access control. Data link layer means switch will come, switch will work based upon the mac address table, right? So this mac spoofing will happen. Okay, so and then ARP poisoning. Okay, like ARP means address resolution protocol. That will happen, sending fake ARP replies to the rewrite the traffic. So they will send the fake ARP replies, and then they will rewrite the traffic. Okay, so that type of attacks will happen. So here what we need to do mitigations, we have to port security on the switches. Like on switches we have to keep port securely. Okay, and then we have to maintain VLAN segmentation and proper configuration. Okay, so we will have the VLAN segmentation and proper configuration stuff. Okay, so that we need to take care of it. So again I'm saying, you no need to focus much on the attacks and mitigations here. Just focus on the OSI model, function of OSI model in each layer, what type of work will be happening. Okay, because OSI model comes under network device, networking, right? You have to focus on that. Later point, if someone asks you like what type of attacks will happen in the OSI model, then you have to say this type of attacks will happen. Okay, so coming to network layer, there we will have IP spoofing. That means so they will create the fake IP, okay, fake source IPs, and then they will send you. So you will think like that is a from original IP you are getting the message. Okay, that type of attacks will happen. Then routing attacks, okay, and denial of service attacks. Okay, DOS attack we can say. So as I mentioned, that you will get it in the cybersecurity attacks. I'm going to discuss that in upcoming classes. So how we can mitigate those, how we can stop that? Okay, so for that we need to maintain the firewalls and IDS and IPSs properly. Okay, access control list, ACLs, these ACLs will come in firewall, so there we have to place proper controls, okay, to stop that type of attacks. Okay, so that is very important to protect from these attacks. Okay, and then in transport layer what will happen means session hijacking, okay, sync flood, and then UDP flooding. Those are the some attacks which will happen in which will occur in the transport layer. Again, for mitigations, so we need to place firewall strongly, and we have to enable SSL TLS certificates, and then strong session management. I told you, right? So sessions, so maintaining the sessions is very important. We have to place strong session management there. Okay, so that is the mitigations for that. And coming to session layer, here we'll get the session hijacking, like stealing the cookies, tokens. Okay, so such type of attacks will happen in this. Like there is a concept called cross scripting. Okay, so that comes under session layer. So we can also see relay attacks, like reusing the valid session data. Like we will have some kind of attacks there. So that attacks will happen in the session layer. In presentation layer, malware injections. Like malware injections means malware is nothing but malicious software. So hackers will inject malwares into the applications. Okay, so to avoid these mitigations, what we need to do, we need to enable the strong encryption. Like we'll have strong encryption methods. Okay, so that we can discuss in upcoming classes, that we have to enable. Okay, and we have to place antivirus on your systems, on your servers. Okay, so that it will scan it, and it will identify the malicious softwares on your system, so that we can stop that things. Okay, like if something is running on your system, malware like malicious softwares, like virus, worm, trojan, rootkit, and all, this antivirus will do the scan, and it will identify in which location that malicious software is there. It will give you that particular path. We can go to that particular path, and we can delete it properly, and then freshly we can run one more antivirus scan, so that it will give you whether that malicious software was properly removed from your system or not. So like that, that antivirus will work. So don't worry, these all things in upcoming classes we are going to discuss when cyber attacks comes. Okay, the topic comes, right? We will be going to discuss on that particular attacks. Okay, so that is about presentation layer. Coming to application layer, there we could see the SQL injection, cross-site scripting, phishing, ransomware, buffer overflow attacks. Okay, for this again, we have to place web application firewalls properly. We can also call as WAF. WAF means web application firewalls. And we have to say to users like how to access, or how to keep their URLs securely. So we have to guide them, we have to give training to them. They should not download any softwares, right? So they have to if they want to download any softwares, they have to download it from the Google Play stores, and we have to see whether it is a genuine software or not. I cannot directly go to Google, and I cannot download directly from the Google. So these all kind of user awareness training we have to provide to the users whoever is using this particular application. So that's why in real time also in companies, every monthly quarterly what they will do, they will provide the cybersecurity awareness training to everyone whoever is there in that companies. And also in every company they will place the cybersecurity awareness trainings. That is mandatory for everyone. They have to complete those training. If they complete those trainings, then they will get to know, okay, what will happen, what type of malwares will be there, how I have to protect my system from the malwares. That all stuff they will get to know from that particular trainings. Okay, that's why they will place such type of trainings in the real time as well, like in companies. Okay, so this is about OSA model. Okay, and how it will work. As I mentioned, it's a reference model. um, Using this model, okay, they have implemented the one more model, that is TCP IP model. TCP IP model is a in real time we are using the TCP IP model. Okay, so TCP IP model, here what will happen means, so there we will have, so in OSI model total we have 7 layers, right? But here we could see only 4 layers. So let me take that picture from online. Yeah, these all are the OSI model TCP IP models examples. Okay, so if we could see here, let's take this. Okay, so application layer, presentation layer, session layer we have, right? So whatever functions are happening in this OSI model, okay, all those functions will happen in 4 layers: application layer, presentation layer, session layer. These 3 layers function will happen in one layer called application layer. In TCP IP model we'll call like application layer. In this application layer, these all 3 functions will happen. Whatever functions are happening in these three layers, all those functions will happen in one layer, that we will say application layer. Transport layer function, transport layer only there. In network layer function, we will say internet layer, like whatever is happening in network layer, that will happen in the internet layer. Coming to data link layer, physical layer functions, these 2 layers function will happen in one layer, that is in net, that is network access layer. That is network access layer. Okay. So if I say simply, okay, OSI model will have 7 layers, TCP IP model will have 4 layers. So whatever functions are happening in these 7 layers, okay, so those all 7 layers function will happen in 4 layers in TCP IP. In TCP IP. Okay. Any doubts here? Any doubts here? Okay, cool. So if you don't have any doubts, okay, then I can say please go through this OSI model, TCP/IP model, and then, as I mentioned, try to understand what type of attacks are happening in each layer and what are the mitigations for those layers. I have highlighted, okay, each and everything in this class, right? If you can go through this class, it will be easy for you to understand the concepts. Okay, so OSI model, TCP/IP model we discussed in today's session. In upcoming session, I'm going to discuss about the IP addresses and port numbers. That is our next class. Thank you so much for joining this session, guys. Okay,